Welcome. This question says, what is the latent heat of crystallization of solid gold if it takes 20,100 joules to melt 300 grams of the metal? So we're envisaging basically a system where we have some kind of cube of solid gold and we heat it up using some kind of heat source like our Bunsen burner, and we convert it into a nice puddle of gold. And let's just remind ourselves of another thing. If we plot a graph of temperature versus heat, and we start off with a solid, what happens is as we add heat to the solid, its temperature rises until we get to its melting point. And then the material melts, and when it's all melted it starts getting to be a higher and higher temperature liquid. So this is the solid bit, this is the liquid bit, until it's at its boiling point, and then it vaporizes, and then we get a hotter and hotter vapor. So it's a good pattern to have in mind. At atmospheric pressure, there are some materials which actually go straight from, this is the vapor, straight from the solid to the vapor, and they skip the liquid phase. But the vast majority of materials go from solid to liquid to vapor. The slopes of these temperature changing bits are dictated, they're not equal to, but they're dictated by the specific heat capacity for that material. And the width of these plateaus are dictated by the latent heat. There's the latent heat of fusion or crystallization, and there's the latent heat of vaporization. There's two distinct numbers for each material. And if I've exaggerated anything in this diagram, is I've made these plateaus much narrower than they often are in practice. They're huge. So we're talking about this plateau here, and we want to characterize how much energy it takes to melt a kilogram of solid, basically. And we'll call that amount of energy our latent heat. So we can say our latent heat is the amount of energy we need to use, how much heat do we need to use, divided by how many kilograms of material we had. So there's our definition. So in this case, we're looking, I'm being a little bit sneaky. Well, that's not particularly sneaky. That 20,100 is not sneaky, but I'm being just a little bit sneaky to see if you're just awake. And you can't put grams in, of course. You got to go 300 times 10 to the minus 3 because you want to be in kilograms. So basically we go L is equal to, and this is going to be the zeros cancel, so that's going to be 3 goes into 26 times, carry 2, 3 goes into 21 7 times, and then we have the 10 to the minus 3 on the bottom, which becomes 10 to the plus 3 on the top. So that would be joules per kilogram, and that would be our latent heat of crystallization or crystallization. So there we have it.